Okay, I open again because my computer, uh, I say, stopped because of the my clustering command. So I want to reopen. I want to reopen the data frame like this. So when you do very large analysis, spending a lot of time, you have to save the file like this always. This is very important. So it has stopped after let's say after just clustering of them. So I want to index. I want to on name to 0. Unnamed 0. Okay, good. I want to reduce the dimensionality. So this dimensionality is like this. So I want to reduce the dimensionality. So for this, so maybe you remember from the what was that coronavirus analysis. So scikit-learn, we use the scikit-learn for the decomposition. Import PCA. No, PCA. So we could make number of components to 100 and we can make X by use X PCA pit transform X. Okay, so now we have 200 and we can reduce 0, 0,2, 0, no, 0,1. Then this will be no shape. This will be the PCA result. So I want to see the results. Okay. So data frame PCA. Data frame PCA and Cbon scatter plot data PCA x equal 0, y equal 1. So this is again, this is very weird plot. So which means maybe the other component have a lot of information. So I don't want use this not informative PCA result. So manifold import TSNE. So TSNE number of job. No, hopefully it does not take too much time. Hopefully. Okay, so Disney is done. So I'll make Disney data frame also. Disney. What happened? What happened? I made some mistake, but no problem. And okay. So this is really weird. Scatter plot. I didn't expect, but still it will give us some information. I was thinking that in the way. So I will increase this plot. Then we can see some clusters. We can see the clusters. So maybe we can say, okay, the closely related clusters may have some, let's say, well related, very well related promoter position, right? So maybe these guys may have highly related composition of promoters. So maybe we can again second on cluster means clusters, no, cluster, no, okay, means, okay. So again we can load k means number of cluster would be, I don't know, 20 or random state is 111 and fit. Cam fit predict get predict x Disney and y. Okay, so data frame Disney and y is y. Alright, so again let's plot this again here, and hue is y, right? Okay. Let's see. Okay, actually the reason why this shows bit gradient, I say color scheme, is that we made this as actually number, so we can change the S type as string. We can change it, and let's see. No, why? cluster plus underbar. Okay. Let's see. So this is kind of bug. So because it is computing that because it yes. So the Seaborn actually computing if we have these numbers, even though it is string. So we have to put some real string cluster, such as cluster here. Let's change the number of clusters again, like we did in coronavirus. Maybe 40. So now we have certain groups which that I don't like at all, but I think we can narrow down. Number of clusters. Okay, so fair enough. So let's see the data frame. So and y value count. So it shows so many number of clusters. And I will select minimum one. Okay. So cluster 27. Okay. Okay, so now we have index. Okay, this index is coming from so this, right? So these orders, the right. So this index is unnamed 0. Unnamed 0 is the gene names, the transcript names, and exactly the order goes to X and Disney, right? So we can use so nasty. So we can use I'll remove this one also. Like this. Okay, then these genes are sharing a similar profile of the very similar profile of promoter composition. happen? Okay, so we don't have, so we can rank set index to 0, right? So, give me the result. Okay. Standard scale. So this is standard K1. Then let me have 0. So this shows that the profiles is kind of clustered each other, right? So these profiles kind of clustered each other. So this actually give us some more, I mean, so this actually give us another group of the sequences, I think. So I retrieved the one cluster, and this one cluster has some more clusters. So actually, if I want to, let's say, if I want to try more reasonable one, and then I think I have to use more detailed I say method to retrieve certain group. Then how do I do? I think there is one way to do it. So we have Disney. So we have Disney, and Y is there, and I want to add index there. I want to add gene name. So gene name, data frame, feature count, index, origin name. So, right? Okay, I want make index, set index. 그렇죠? We can retrieve. What is the famous Arabidopsis org tear? So this is tear 10. So I want to retrieve very famous gene della. So we have della protein guy. So this guy's name but I'm not sure this is tier 10 or not. So this is the problem. Actually, so they didn't explicitly tell me any information of reference genome. I mean reference gene set. Anyway, I will check. That one. So this was the cluster 15, and we can retrieve 0.1 matrix by use and minus the by use and profile we minus profile. Good. We can minus profile and how do we do? How do we? So what I'm doing is the calculation of Euclidean distance. Euclid 거리, Euclidean distance. So this must be in this way, right? So this is the way. So I don't want to put the root. I will just minus for each component, and I will let's say put scale. So I already minus. I did minus and scale. So and what was that? Sum, right? So and sum. I will put sum there. And this sum. No. This sum and this sum. Axis 1. Okay. The shape. Okay. So we have the Euclidean distance for every genes, right? So I will put ED, Euclidean distance, and I want to plot it. If we have certain, if we can see very good very good barley or not. So it is not easy. It looks like. Beans. 100. It's 100. So still there is 1,000 genes that shows very low distance. So I will limit lim. Maybe I can AD 100. Okay. So this is the way we set a kind of value threshold. So I will put. So let me just put some 20. 20 is our threshold. So it's not based on the data. So it is a bit messy right now. So I don't know if I can put very good threshold for this. Okay, so let me just put 20. Or I will show you top 10, right? Top 10. So top 10 is best approach, I think. So numpy arg sort, so arg sort, and ed. And the first one is like a minimum one, right? So the first one is minimum one. So arg sort give us index. So each sort and it will give us sorted index. So everything is in index. So top 10 is the index. So minimum value. It will show you minimum values here. So and then what? And then what? So this will be is based on that one. Okay, right? So gene name. Huh? So we made it index, right? And I will change them like this, and index 0 to 10. Okay. So this is all that is and this. Okay. So, okay, these are all in the cluster 15. But anyway, so I will show you this again. So candidate gene. No. Candidate genes 하고 그렇죠. 이렇게 가야죠. Okay. Are you sure? Are we show you the? What is that? So in this case, we don't need to do this. 아. 에이, 진짜. This must be because some of them shows two similar profile. So that's why it will not cluster. Then okay, I will no. Maybe then low cluster first. No. Core cluster first. No. Why? 아, 진짜. Then I will not do standard scale. Anyway, I don't know. I have to see by my eye. So let's see. Test CSV. Okay. Let's see the status. So these guys have nothing, right? So these guys have nothing. 아씨 짜증나. These guys has nothing. Then let's change. 이런 동작. 아휴. I will change the how do I select best example? How do I select best example? Maybe I will put some MP some. Okay. So the first one is good. The first one is good. So the first one actually, what is the function? What is the function? Let me check the function. Then let's go. So knock. Okay. So okay. So this is huge hove. This is a huge hove. Let me check. How knock protein. Knock protein. Okay. Again. candidate gene. So candidate gene. These are all 17 and okay. So knock guys. Knock guys are so some of them shares the motifs, right? So these highly shared motifs are there. So this is why it shows us really similar profile by Disney. And let me see what is the result. What is the result? So the results show. So this was the knock, and the other one will be what? I don't know. So I will. So I think we can retrieve. So PPR superfamily. So this is a PPR superfamily. Is there any correlation plot in this database? No. So anyway, so this is how we doing. So I spent too much time. So I will stop here. So next time we will see how these related genes actually displaying some kind of expression correlation or functional similar functional context. So that will be next class. Thank you very much.